Okay, this is section 7.5 on solving exponential and logarithmic equations. The main thing you got to remember in this section is that to solve exponentials, we use logarithms, and to solve logarithmic equations, we use exponents. Okay, you use the opposite one, the inverse of it, to think of it one way so that you can solve it. All right, let's start. Oh, and as always, remember you can pause whenever you need to. Try the problems on your own first before you see the actual solution, the actual answer. Okay, here we go. Okay, let's start with number 1, which is almost completely solved for us already here. It says 125 to the 2x power equals 25. So as you can see, the very first step that they took in this problem is that they wrote the 125 as a power with base 5. 5 to the third power is 125, leaving the 2x up there. And then you use the power of a power rule that you learned from Algebra 1, which is 3 times 2 is 6x, so 5 to the 6x power. And the 25 on the right side became 5 squared. Now that you see that they have the same base, that means that if two powers have the same base and they're equal to each other, that means that their exponents are the same as well. They're equal to each other. So 6x equals 2. Finally, the last step is to divide by 6. And there's your final answer. X equals 2 over 6, which we simplify down to 1 over 3. Please don't make the rookie mistake of writing 3. That's not the same thing. Okay, let's do the same thing here. They already started for us again. 2 to the 3x minus 3 equals 64. You break them down so that they have the same base. On the left side, there's nothing you can do. It's already 2 to the 3x minus 3. You cannot break down the 2 any further. On the right side, though, 64 is 2 to the 6th power. Now that you see that the left side and the right side are two powers with the same exact base, we can make the exponents equal to each other. You can basically cancel the bases. So we get 3x minus 3 equals 6. And then we add 3 to both sides. And so 3x equals 9. And then we divide by 3. And so x equals 3 is my final answer. Alright, number 3, 81 to the 3x power equals 27. I'm going to try to do the same thing again. I notice that 81 and 27 can both be broken down to a power with the same base. What is that base? Not 9, right? 9 times 9 is 81, but you cannot break down the 27 as a power of 9. But you can break them both down to a power of 3. So 81 is 3 to the 4th power. You can check that on your calculator if you're unsure. And 27 is 3 to the 3rd power. Now on the left side I have 4 and 3x as power, so I'm going to multiply them by each other to get 3 to the 12x power equals 3 to the 3rd power. Now that they both have the same base, I can pretty much cross it out and set the exponents equal to each other. 12x equals 3. And finally divide by 12 to solve. And so my result is x equals 3 over 12, which simplifies down to 1 over 4. And that's my final answer. Alright, 4, 5, and 6 say solve the equations, round to the nearest 10,000th, check your answers. To start, take the logarithm of each side. Okay. Now it's giving me those instructions because for all three of these, it's impossible to do what we did in the last few problems. We cannot break those numbers down to the same base. So what we do instead is we take the logarithm of both sides. Okay, that is our second option when we cannot break them down to the same base. This second option actually is possible for all the logarithmic equations we've done. So we could have done this in number 1, 2, and 3. We just prefer to break them down to the same base. It's sometimes a lot easier and there's no need for a calculator most of the time. 4, 5, and 6, we're going to need a calculator to solve. Okay, let's start with number 4, which is almost completely done for us. It says 6 to the 4x power equals 234. You take the log of both sides, and we're using the common logarithm here, okay, base 10. Why? Because our calculators can handle those very, very easily. Log of 6 to the 4x power equals log of 234. Then what they did is they took the 4x and they brought it down to the front as a coefficient, so it becomes 4x equals log of 6. Then what you do at the end, since you want to isolate the x, is to divide by 4. and divide by log of 6. So you get log of 234 over 4 log of 6. And now it's just a matter of punching that into your calculator. Log of 234, according to my calculator, log of 234 is 2.369. 2.369. And log of 6, which I need to multiply by 4, log of 6 is 0.778. What I'm going to do now is divide those numbers. First multiply 0.778 times 4 and then divide those numbers. So 2.369 divided by 3.1126. And so my final answer is approximately 0.7612. It says round to the nearest 10,000th, so that's four digits, 4 decimal places. That's your final answer. All of these, of course, are approximations because we're using the logarithms in a calculator to solve them. Okay, now that we understand the concept, let's look at number 5. It's already started for us as well. 3 to the 5x equals 375. Once again, we're going with this route because 3 and 375 do not have a common base. Okay, so we take the logarithm of both sides. Log of 3 to the 5x power equals log of 375. Then what you do is you take the 5x and turn it into a coefficient instead of an exponent. 5x log of 3 equals log of 375. Then to isolate the x, you're going to divide by 5 log of 3. You divide by 5 to cancel the 5. You divide by log of 3 to cancel the log of 3 on both sides. 5 log of 3. Now all of that work, you just need to do it in the calculator. Do it slowly, do it carefully so that you don't mess up. Log of 375 divided by 5 log of 3. You can enter it all on the calculator at the same time. My calculator is giving me an answer as x equals 1.0790. If you're not getting that, check your calculator. Do this, do the numerator. The denominator is 5 times log of 3, and then do the division. That's what you should get. Okay, let's look at number 6. 7 to the 3x power minus 24 equals 184. The first thing you need to do in one of these, once again, I see exponential, so I'm going to use logarithms to solve it. But the first thing you need to do is get rid of that 24. That 24 needs to go to the other side. You need to add it so that it's not in the way. It doesn't belong. So what I'm going to do is add 24 to both sides. So I get 7 to the 3x power equals 208. Right, 184. Then take the log of both sides. We do this so that we can bring the 3x down as a coefficient. Log of 208. Take the 3x that is now a power but turn it into a coefficient. 3x log of 7 equals log of 208. Finally, to isolate the x, I need to divide by 3 log of 7. Divide by 3 log of 7. Once again, we do that so we can cancel the 3 and cancel the logarithm. And there's your final answer. Just put that into a calculator. Log of 208 divided by 3 log of 7 is 0.9143. 4 decimal places because it says to round to the nearest 10,000. That's your final answer. Okay, now let's apply this way of solving equations to this problem right here. Okay, it says there are currently 100,000 people in a stadium watching a soccer game. When the game ends, about 3% of the crowd will leave the stadium each minute. At this rate, how many minutes will it take for 3/4 of the crowd to leave the stadium? So a percent increase, percent decrease problem, that means that we're going to use this exponential formula, right? Where A represents the initial amount, B represents the growth rate or decay rate, okay? X represents the amount of time that has passed, and Y is your final result. So what we have here is that there's 100,000 people in the stadium. That's A. So Y equals 100,000 times b to the x power. Now I left empty parentheses there for b because I need to figure out what b is. It says when the game ends, about 3% of the crowd will leave the stadium each minute. So is that increase or decrease? That's decrease, right? By 3%. So if I want to turn it into a decimal form, remember, always start with the 100%. Add or subtract depending on what you have. In this case, we're subtracting 3%, which leaves me with 97%. And what you should put inside of the parentheses here is 97% in decimal form, which is 0.97. There's your equation. Okay. Now the question is, at this rate, how many minutes will it take for 3/4 of the crowd to leave the stadium? So the initial amount is 100,000, but we want 3/4 of the crowd to leave the stadium. Think about it. How many people are left if 3/4 of the crowd leave the stadium? Well, half is 50,000, right? A quarter is 25,000. So if 3/4 leave, that means that 1/4 is left. So there's only 25,000 people left in the stadium. So what you should do to solve this is set your y as 25,000, the number of people left. Not the number of people that have left, but the number of people that are still in the stadium. There's your equation that you need to solve. And to solve this, the first thing we're going to take is first step we're going to take is to get rid of the 100,000 by dividing it on both sides. Divide it on this side as well. And we're going to get 1/4 or 0.25 on the left side. You could divide on your calculator, or you could think cancel 3 zeros and it's 25 over 100, which is 0.25, equals 0.97 to the x power. And now we're going to apply the way we learned to solve these equations now. We can solve this using logarithms. Take the log of both sides. Let's continue over here. So log of 0.25 equals log of 0.97 to the x power. Then what we're going to do is bring the x down as a power. So it's going to be log of 0.25 equals x log of 0.97. And finally, since I want to isolate the x, I'm going to divide by log of 0.97 on both sides. Divide on this side too, log of 0.97. And my final answer is, after doing this on a calculator, my final answer is log of 0.25. Calculator says 45.5. Now it doesn't say to round up to what or down to what, but since we're talking about minutes, I'm just going to round it up to 46 minutes. So in approximately 46 minutes, 3/4 of the crowd will have left the stadium, leaving only 1/4 in the stadium still. So on these problems, we're going to be solving logarithmic equations, and in order to solve those, we're going to be using exponents. We're going to convert them into exponential form in order to solve it. Okay, so remember, the main thing to remember here is, if you see an exponential, you're going to take logarithms to solve it. If you see a logarithmic, you're going to convert it to exponential to solve it. Okay, you always go with the other form in order to solve this. So let's see, log of 2x plus 4 equals 3. They've already started it for us. What they went ahead and did is that they took the 10, the base 10, raised it to the third power, equals 2x plus 4. Okay, but instead of writing 10 to the third equals 2x plus 4, they wrote 2x plus 4 equals 10 to the third, which is the same thing. After you subtract the 4 and multiply 10 times 10 times 10, you get 2x equals 996. And therefore you divide by 2, so x equals half of 996, 498. And there's your final answer. Okay, but let's start one on our own. Log of 4z minus 3 equals 2. First thing we do is kick out the 3. It doesn't belong there. So plus 3 on both sides, we get 5. Log of 4z equals 5. Then you figure out what is the base here. Now since it's not written, that means that the base is 10. So we're going to write 10 to the 5th power. Remember, not to the 4z power, to the 5th power. You're going across the equal sign. 10 to the 5th power equals 4z. Now if you want to solve for z, you're going to divide by 4. 10 to the 5th power is 10,000? No, 100,000. It's 100,000. And then we're going to divide by 4 to get our final answer. 100,000 divided by 4, so z is 25,000. Alright, now let's look at this one. Log of 2x minus 8 equals 2. The argument is 2x minus 8. There's nothing to kick out here. Do not try to split up the 2x and the negative 8 into a division problem. Okay, do not confuse this with the quotient property. What we're going to do is we're going to turn it into exponential form. The base is 10. So 10 to the 2nd power, remember, go across the equal sign for your power, equals my argument, which is 2x minus 8. 10 squared equals 2x minus 8 is what it looks like in exponential form. 10 squared is 100. We add 8 and we get 108 equals 2x. We divide by 2 and we get x equals 54. And that is your final answer. Okay, the next ones are going to get a little bit more involved. 14, 15, and 16. 14's already started for us. There's a lot of work already done. 2 log of x plus log of 4 equals 3. First thing we do is take that 2 and turn it into an exponent. Log of x squared plus log of 4. Then we put the two logarithms together using the product property. Since it's addition, we turn it into multiplication. So log of 4x squared equals 3. Then we turn it into exponential form. Now that we have a single logarithm, we can turn this into exponential form. 10 to the 3rd power equals 4x squared. That's this step right here, turning it into exponential form. Simplify, 10 to the 3rd power is 1,000. Divide by 4, you get 250. That's how we got this step here. And finally, to solve it completely, you got to take the square root of both sides. Because in order to get rid of the square, you take the square root. So x is approximately 15.81, according to the calculator. 15.81. Now 2 decimal places, it doesn't say how many decimal places. We're going to keep using at the most 2 if necessary. Alright, let's move on to the next one. Okay, it says log of y minus log of 4 equals 2. I see that they already have no coefficients in front, so there's nothing for me to simplify there. I can put them together, which should always be your first step. Try to put the logarithms together into one using the same base. They do have the same base, which is 10. So, and I'm using the quotient property, it turns into log of y over 4. And now from that step, now you can turn it into exponential form. The base is 10, the power is 2, and your argument is y over 4. 10 squared equals y over 4. 10 squared is 100 equals y over 4. And now to solve for y, you're going to multiply by 4 on both sides. And there's your final answer. Y equals 400. Alright, let's keep going. Log of 10 plus log of 2x equals 3. Again, same basis. They are both common logarithms, so we're going to put them together. Using the product property, this is log of 10 times 2x, which is 20x. Turn it into exponential form. The base is 10, so 10 to the 3rd power equals 20x. 10 to the 3rd is 1,000 equals 20x. And then finally divide by 20. 1,000 divided by 20 is 50. So x equals 50. And that is your final answer. Okay, to close this section, we're going to do an error analysis problem. It says your friend used the following steps to solve the equation log of x plus log of 6 equals 4. What error did he make? What is the correct answer? So let's examine what happened. Log of x plus log of 6 equals 4. Then he wrote log of x over 6 equals 4. Then he turned it into exponential form. 10 to the 4th power equals x over 6. And then finally he multiplied by 6 on both sides to get 6,000. Do you see the mistake? Should stand out to you right away on the very first step. Okay, he writes the equation, and then on this step right here, the problem does not say minus, it says plus, so we should use the product property. He should have written log base 10 of x times 6, or 6x equals 4, not x over 6. Then turn it into exponential form. 10 to the 4th power base 10 exponent 4 equals 6x. 10 to the 4th power is 10,000. And then divide by 6 to get your final result. 10,000 divided by 6 is, according to my calculator, well, it's 5,000 over 3, so it's going to be 1,667. Let's round it to that. So what was the error? The error was that he used the quotient property instead of product property, so we're going to say should have used the product property. Not the quotient property. And what is the correct answer? It's right there already in the box. X equals 1,666.66666. Keeps going forever, but we're rounding it to 1667.